So today's topic is microservices, and I think I mentioned this a little while ago. Kind of like I've actually been giving versions of this talk for 2.5 years now, and it was all about, and the big idea was decomposition, like breaking apps up into services. And then of course the term microservices came along, and I put microservices in the title and just to be buzzword compliant. But the big idea is you break up the app into services, and it makes your app much more deployable, much more scalable, and in some ways easier to develop. And it also makes it a lot easier to embrace new technologies as they emerge. And I'm going to kind of, the whole talk's about that. So a little bit about me. So I actually got my start programming back in the 80s, doing Lisp systems. So I actually spent 7 years building various kinds of Lisp systems. Compilers, runtimes, frameworks, IDEs, garbage collectors, and all of that kind of stuff. I met Robert, wasn't it? You were doing Smalltalk back then?
Yes, I was.
Yeah. So that was a really long time ago. Yeah, there was like 86 to 93. And then, fast forward to 2005, 2006, I wrote a book, Pojos in Action, which was all about how to build apps with Spring and Hibernate, which back then were these radical new technologies that were, sort of transforming enterprise Java development. And, they're actually still pretty good. I still use the Spring framework today. And then back in 2006, this was really interesting. I run the Java users group up in Oakland, and we had an evangelist from Google come talk about APIs, and they were talking about Google Checkout. And then this Amazon evangelist showed up, and I was thinking he was going to talk about APIs for building books, for buying books. And instead, he talks about APIs for provisioning servers. And this like blew my mind. So much so that, I kind of signed up for the AWS program that was still like a kind of closed beta, and I started tinkering with it eventually. And that created an open source project around that, and that turned into my startup, Cloud Foundry, which was a PaaS for deploying Java applications on Amazon EC2. And then that got acquired by SpringSource back in 2009, shortly before SpringSource was acquired by VMware. And I always like to make the joke that this was not drawn to scale in terms of market cap. Cloud Foundry was really a plankton. Not even necessarily that. It was tiny. It was like me, it was Robert, and another guy. And I actually had spent 4 years at VMware, which I then Pivotal, which I then left a year ago with the goal of figuring out what to do next. So I'm kind of pursuing some startup ideas and also doing consulting around NoSQL, cloud, AWS, microservices, and a whole bunch of trendy application topics. So that's me. So really the agenda is first kind of like look at the motivations for using microservices, dig into what it means, and then sort of explore various different aspects of the design of a microservices-based application. And then I added a little section on the end where I just kind of talk about some of the specific technologies that I'm using in my startup's app. And please feel free to ask questions at any point, because I think I've got enough slides for about an hour, but we've got like 90 minutes, so we can make this nicely interactive. So, let's imagine that you're building an online store, kind of sort of Amazon.com type application. And, if you're like me, a few years ago anyway, you would have probably built an application that looked like this. So, you'd have a presentation tier, storefront UI, and that would maybe serve up HTML. Of course, today it would expose a REST API to mobile devices. And then you'd have various back-end services like a service for product info, kind of the product catalog, a service for recommendations, a service for reviews, a service for dealing with order processing, and so on. So you'd sort of have this logically modular architecture, and it would use technologies like Spring and Hibernate and all that kind of good stuff. But then what you end up doing is actually packaging your nice, logically modular architecture up inside a single WAR file that you then run on a server like Tomcat. And you just sort of have this, you have the application, just this monolith. So sort of who builds apps like that still? Anyone? Yeah. And if you're really lucky, you could have 1 million lines of code in there because you know, a team of developers busily adding code every day. Before long, you've got this massive application. But on the one hand, you know, this is not bad because apps like this are actually quite simple to develop, test, and deploy. In particular, you know, deploying your monolithic application just means copying the WAR file onto your Tomcat server and maybe restarting Tomcat. That's really, really simple. And you know, also it's pretty easy to scale, right? You run multiple copies of your application behind a load balancer, and you've got this app that can scale to handle increasing load. So that's really nice. And you know, the apps that I built, actually including the original version of Cloud Foundry, had this monolithic architecture. But the problem you run into, and maybe some of you are experiencing that, is that when your applications become large, this monolithic architecture really just causes a whole bunch of problems. Causes you a lot of pain. And with the original version of Cloud Foundry, we had pain as a result. Number one, you know, a large, you know, monolithic application tends to be pretty intimidating. You know, imagine being a new developer and you're given a task to make changes, and you've just got this massive system that you have to figure out, and where all the pieces are, and so on. It probably has quite a complex build system. So you know, it's just scary. And you know, once developers get scared, they don't make changes properly. The quality just deteriorates, and it's sort of a death spiral. A large monolithic application really isn't amenable to being redeployed frequently, because you actually have to redeploy the entire system, which can actually be kind of risky. You can actually have long-running background jobs, quartz jobs, that get interrupted when you take down the server and it leaves the system in an inconsistent state. I've had that happen. And also, because all of your eggs are effectively in one basket, there's a lot of fear associated with deploying a large monolithic application. So there's this fear of change, so you don't want to deploy frequently. And that just sort of, you know, you got long QA, and it just really slows down development, but especially compared with the state of the art, which is deploying changes into production many times a day. You can't really do that with a monolithic system. I think. Probably there is someone who's doing that. Another problem you have is that, you know, a large monolithic system can overload your IDE. You know, you suck a big code base, especially a Scala code base, into your IDE. It's going to run incredibly slowly, and which makes you less productive. It's also going to slow down your container, slow down your application server. You know, if you've got a large application, it can easily take many minutes to start up. And if that's part of your development cycle where you make a change, restart the server, try out, test the change, you know, you're going around this quite long cycle. And once again, you're quite unproductive because your application is large. And then also, sort of a large monolithic application is really an obstacle to scaling development. You really want to break up your engineering team into sub-teams where each team focuses on a specific functional area. And the problem you run into when you have a monolithic architecture is that in order to get changes into production, you might actually have to have a lot of communication and coordination between the various teams. So the UI team, you know, who are constantly changing things, and they just want to redeploy the new UI to do A/B testing, for example, can't do that because the back-end team has broken some piece of the system, and they haven't committed the fix yet, and so you can't push the latest version of the code into production. So it's kind of painful. And then I think a really big problem is that a large code base really ties you to the technology choices that you made at the start of the project. Because as you know, if you actually, you can't, you know, there's a lot of frameworks out there where you have to kind of embrace them 100%. You can't bolt them onto your legacy app without actually having to rewrite the entire code base, which is prohibitively expensive and risky, and you know, rarely works out successfully. And you know, I think this is one of the reasons why you find, you know, every so often I run into people who are still using EJB2 and Struts 1. It even gets worse than that. I mean, I've even heard of people who are using like some custom macro assembler language from the 60s because they got some mission critical system that they just can't rewrite, you know. So anyway, so I think, you know, that's a key problem with the monolithic architecture. It doesn't let you freely try out new languages and new frameworks that easily. And that, I think, you know, leads to the sort of zombie-like state of many applications. Especially today, because things are new stuff, some of it good, some of it not, is coming out all of the time, and it's just good to try it out. All right, so those are the problems with the monolithic architecture. Even though it's, interestingly, it's actually simple in some ways, but it doesn't really scale to deal with complex applications. Later on, I'll tell you why microservices are a bad idea as well. But, you know, there's no silver bullet, right? So anyway, a few years ago, I read this book, The Art of Scalability, which was written by some guys who had worked at, eBay and PayPal. So it wasn't actually that technical a book. It was really about scaling architecture, scaling your engineering organizations. They later came out with a more technical book, the like 50 Rules of Scalability. But this book was fascinating, and one reason it was so interesting is that they had this three-dimensional model of scalability, the scale cube. And so there's 3 axes, 3 different ways of scaling your application. And so one of them was the x-axis scaling, which is just a horizontal duplication where you just run multiple copies of your app behind a load balancer. So that's sort of the standard thing that we've been doing for years. Then there's also z-axis scaling or data partitioning, where you use, say, at the database level, the value of a column to determine which server that particular row should reside on, so that's sharding. But you can also do that at the application level. You use an attribute of the request to route that request to the server that can handle it. Maybe you route free customers to one set of slow servers and paying customers to the much faster servers. So this sort of x-axis thing kind of works at both levels. And then what's really interesting is there's y-axis scaling, or functional decomposition. And that's kind of different, whereas x-axis and z-axis scaling are about running different copies, or the same copy of the application multiple times. Y-axis scaling is actually splitting up your application into things that are different. So it's sort of functional decomposition. And really that's kind of the essence of the whole microservices thing, or the service-oriented architecture, is that it's about functionally decomposing your system into a set of services. So if we apply that to this online store, we end up going from this to a system that looks like that, where each of what were logical modules of your system are now actually separate physical running services that can be independently deployed and scaled. So if we want, we could apply, we can also split up the front end as well. So instead of a monolithic UI, we now have a modular UI where, you know, different mini web apps handle different parts of the UI. And then we can apply x-axis and z-axis scaling to that, so sharding where it's appropriate. You know, most services we want to run multiple copies of for availability and scalability and so on. So that, you know, that in essence is the big idea. And then what are these services? So there's a whole bunch of different deployment options. So if you take Netflix, for example, you know, each kind of service is an AMI that gets, and then they run multiple EC2 instances based on that API, based on that AMI. So it's really a service per VM, or it could even be a physical machine if you're running in your own data center. Now, of course, Docker is one of the latest hot things, right? And it just so happens that Docker is a really great way of deploying microservices, especially because lots of Amazon EC2 instances are quite can actually be quite expensive, especially because, you know, these services might actually be small and they're not fully leveraging a whole EC2 instance. Whereas with Docker, you can have lots of containers running on fewer EC2 instances, so that's quite appealing. And then there are other deployment options, like there was some kind of like Google-like internet company in China where, because they were operating at such a huge scale, they actually deployed each microservice as a OSGI bundle. So that was actually an interesting use of OSGI. So in one JVM, they actually have many small microservices running, which means basically you've got, you know, it's kind of the most densely packed way of deploying microservices, though there's a trade-off with manageability and sort of isolation and visibility into resource utilization and so on. So there's a bunch of different ways that you can deploy these services. But I definitely like the first two, as an EC2 instance or as a Docker container. Okay, and then there are partitioning strategies, like how do you break up the system into services? So one way of doing it is partitioning by noun, and so you could have a service that's responsible for anything to do with an entity of a particular type. So a customer management service or a product info service, or an order service. Or you could partition by verb, where it's sort of there's some service is responsible for a particular use case, a particular action, like checkout, for example. And then there's a few guidelines. There's like the single responsibility principle from object-oriented design that says a class should only ever have one reason for change. It should only ever have one responsibility. And you could apply that concept, that kind of thinking, to service design as well. So a service just has one responsibility. So small, cohesive service. Or you could kind of emulate Unix. So if you think about Unix, right, these sort of command line, you've got all these tiny little utilities, cat, grep, find, maybe some are not so small like or. Actually, I wrote some more scripts the other day. But each one of them's kind of got a small, focused responsibility, but you can combine them together in shell scripts to accomplish, much larger things. So that's kind of a nice sort of paradigm for thinking about microservices. And there's sort of like, you don't want to have too few, because you end up with, instead of one big monolith, you end up with a few medium-sized monoliths, so you haven't exactly solved the problem. And then there are people who argue that you shouldn't, you can have too many. This so-called, from SOA, there's the nano-service anti-pattern. And that's, that's a risk as well. Obviously because there's various downsides with having tiny, tiny services. It can be inefficient because of the runtime overhead of each service. If each service is an EC2 instance, that's a heck of a lot of overhead, right? Just for running 10 lines of code. you know, a real potential problem is too many network hops. You don't want to have a request come in and then bounce between a whole bunch of servers before going back out again, because that will give you a terrible response time. Though interestingly, if a request comes in and you invoke 100 different services in parallel, that will still give you kind of a good response time. So it's really the style of communication rather than the number of services that are involved that determine whether it's good or bad. But then there is this problem that whereas before we have one thing that's complicated, if you then kind of have lots of services, you have lots of small things that are individually quite simple to understand, but now you've moved the complexity into the space between the services, and figuring out what the heck is going on in your system can actually be quite difficult. So there's a whole bunch of trade-offs, and I'm kind of doing some hand-waving here. So that says it's something of an art, and I think it kind of is. So so what does a service look like? Well, here's one. This was kind of cool. So one of the Spring framework has been awesome for many years, and nothing that new has come out, except recently, I think it was a year ago, Spring Boot came out, and I'm going to talk a little bit about that. And this is a Spring Boot application in a tweet, and it's a hello world. It's a RESTful hello world microservice. So yeah, in theory, you could have tweet-sized services, but probably not. Though one of my demo apps I wrote, it was actually it was a service that was written in Sinatra, a Ruby web DSL. And it was kind of like 10 lines of code, and it auto-responded to incoming SMS messages by telling the user to go to a registration URL. And to me, that was actually a legitimate service, right? It was only 10 lines, but I deployed it, never touched it, and the rest of the system was changing around it, and I thought that was fine. But the reality is that I think one of the problems, I mentioned this before we got started, I think one of the problems with the term microservice is that it kind of emphasizes small, kind of too much. Whereas service-oriented architecture, that's sort of a neutral thing, right? You break it up into services. Now, so I kind of think about services and not so much about the micro bit, and work on kind of decomposing your system into meaningful services that kind of solve the problems with deployment and scalability that you're actually embracing, rather than aiming to have lots of 100-line services. So yeah, so less micro, more service. So I think if you look out in the real world, or at least the web world, there's lots of examples of this architecture being deployed. And interestingly, each of these companies, Netflix, Amazon, eBay, they all actually had a monolithic architecture at some point during the life of the company. And then at some point it became too much trouble, and they went through the process of refactoring or rewriting and creating what they would now call, in some cases like 15 years later after they did it, a microservices architecture. So Netflix, they're kind of the hot tech company right now in terms of thought leadership. They've talked about having 600 different types of services in their system. Interestingly, if you do the math, right, I mean, those are not 100-line services, because I think they have more than 60,000 lines of code in their system, right? They're reasonable size. And Amazon, they have a service-oriented architecture as well. And obviously they don't disclose too much about the details, but the high scalability website talks about hundreds of services getting invoked in order to supply all the pieces of data that go on a web page. So if you actually go look at the product details page, right? There's a ton of information on that. There's the basic information about the product. right? So you can imagine there's a product info service, but then there's reviews and recommendations. So there's two services. It actually will tell you when you last bought that product. That's another one. It actually tells you when you can get it, so it sort of kind of knows about shipping type stuff. There's seller rankings. And if you keep scrolling down, there's just like more and more pieces of data. So you could imagine the front end that's assembling that page is actually sort of, broadcast to a whole bunch of services. Tell me what you know about this product, and then assembled that data and rendered the HTML page. It's real interesting. And then of course eBay, who back in the day were the hot thought leader in the tech world. They said back in really long time ago, back in 2006, kind of had some interesting talks on architecture. One of which was actually at SD Forum, the predecessor of SV Forum. So it's kind of very much real world stuff. I don't know if there are big companies out there with massive monolithic architectures. Maybe not so much newer internet ones. Though I did once talk to a financial services company, and I think they had a whopper of an application. Millions of lines of code just packaged up as a monolith, and it must have hurt.
Well, how prevalent is it, do you think, that there's like big organizations that kind of every group wants to do their own thing and reinvent their own wheel? They don't communicate a lot within each other. Is that a problem? I mean, so it's kind of like a microservices, but yet they're not interacting with each other.
Given the dysfunction that's common in large companies, it probably happens.
Okay.
I don't know, but just speculating, I'm sure it does. I mean, it's almost like anything you can imagine bad about software development is being done.
So if you want to be an agent of change and you want to start, integrating those applications within that company, how do you? Maybe it's a different topic, but how would you kind of then try to bridge those different? I mean, with this approach would be the way to bridge it, right? Then, or
well, that's interesting because I kind of look at I think about ESBs, right? Enterprise service buses, and they were the way of tying together all of these sort of different applications. I guess I think about, if you think to me that kind of the change scenario is you work at a company that has a large monolithic application, and it hurts to do development on it. So then the question is, how do we incrementally decompose that monolith into a set of services? I think that's kind of the more relevant question here. So I think if you've sort of got these, bunch of services or apps, and they must be talking somehow. You've got a sort of service-oriented architecture, just not a very good one, perhaps.
not a lot of automation, more Excel spreadsheets.
Oh, yeah.
Yeah.
Interesting. Ping me, though. So, there are a whole bunch of benefits with this approach, right? Number one is, instead of a big monolith, you've got lots of relatively small services, each one of which is easy to understand and easy to develop. So that's definitely good. Less jar, class path hell, which you can run into with very large applications. And I think that, say, one of the motivations for OSGI was really to solve the problem of I've got this giant monolithic application. How do I redeploy different bits of it? How do I deal with class path complexity and so on? And so if you've actually broken your app up into lots of little services, you've eliminated the need for OSGI. Which, at least from my perspective, is really, it kind of reared its ugly head back in 2008 as a developer conferences, and hasn't really been seen since. So I don't see it as that kind of big a big a deal anymore. Though apparently, yeah, there was some, yeah, I guess it's still evolving. Saw an announcement about it. And these apps tend to be faster and simpler to deploy. You know, I use Scala for development, and I really like Scala, but the Scala compiler is really slow. And the nice thing about a microservices architecture is your apps aren't that big anymore, and so the compilation time is much more manageable. And then they're just kind of tiny to move around and push into production as well, so it's just faster. And then interestingly, I mean, at one point, I don't know how relevant this is anymore, but on Google App Engine, your app had to sort of respond to a request within, you know, was it like 30 seconds or something like that? And some web apps don't actually start up that fast because they have lots and lots of initialization to do, and so Google App Engine would just decide that your app is not functioning and kill it. And so, you know, this kind of microservice architecture addresses that problem as well. And then it lets you scale development, right? Like you've got, you know, each team can work on one or more services, and they can develop and deploy and scale their services independently of what all of the other teams are doing. So provided you're not working on features that span multiple sort of teams, then there's no, which a lot of changes don't. They're just sort of within a service. Then this is really, really good. You know, teams aren't having to coordinate and communicate all of the time in order to get their changes into production. They can each work as fast as they need to most of the time. And then this approach also improves fault isolation as well. You know, whereas in a monolith, one misbehaving module that sucked up all the CPU or had a memory leak could bring down the entire monolith. At least in this architecture, it's only going to impact a given instance of a given service, and the rest of the application is going to keep working. So that's quite nice. And then I think a huge reason for using microservices is that it really gets rid of any long-term commitment to any particular technology stack. Because you've now got lots of little apps, and in each one could kind of use whatever framework, whatever language seems fit, right? You know, whatever technology is best suited for solving the problems of that particular service, whatever technology is new, hot, and fashionable, you can just start using it, which is kind of good. You're no longer stuck with Struts1, EJB2. Or whatever legacy technology you picked 6 years ago. So you can kind of think of your system as having two different levels of architecture. So you've got the system level that's saying, well, we've got these services, and each service has this interface, and they communicate using these mechanisms. And that can be the slow changing architecture, perhaps determined by people who use PowerPoint and never write code. But then the individual services kind of have their own architecture, and within reason, the developers of a given service are actually free to use whatever technology they want, provided they implement the official interface. So, and of course, you know, if you've got a REST interface, there's a whole bunch of different technologies that you could use to implement that RESTful API. You can pick the best tool for the job, but also, because each service is small, you know, there's nothing to stop you rewriting a service to try out a new technology. Imagine you know, if you've got a 1,000,000-line app, you're not going to rewrite that because you want to use the Play framework instead of the Spring framework. You know, it's just not feasible. Whereas if you've got, say, a 3,000-line application, if you want to rewrite it using in Play just to see how it goes, that's not going to take you too long, and if it doesn't work out, you haven't wasted that much time. Whereas if it works and you find that play is better than Spring, then you've learned something valuable that you can then apply to other services. And then also, when you start a new service from scratch, at that point in time, you can sort of think, well, what technologies should I use? Which is a different, which will have a different answer to that question than would have had like 5 years ago, for example. And there's all this, you look around today, there's all this really cool stuff out there, some of which is quite good, right? Different languages like Clojure. If you're feeling crazy, you can use server-side JavaScript. There's old-fashioned things like Python. And then, in the Scala world, there's a whole bunch of, Akka is pretty good, Play is interesting. I'm a big fan of Spring Boot. I think it's a great technology for building microservices, but then there's also other options like Dropwizard. And last night, Jason Schwartz from Netflix talked about how they've been using Scalatra, which is a Scala-based web DSL that sort of was inspired by Sinatra, the Ruby-based web DSL. And you can write tiny little programs in these DSLs that accomplish powerful things. So it's sort of, a lot of productivity. But then also, as I said, if it doesn't work, if you're free to experiment, and if it doesn't work, you've learned something. If it does, you've also learned something. And I think this is one of the big benefits of microservices, is you can try new stuff out safely. But having said all of that, there's a bunch of drawbacks. And I think a big one is complexity. To the point that sometimes it can hurt, because now you're developing a distributed system. So whereas before it was a monolithic application, and when service A called service B, that was just a regular method call. It was nice and simple. But now in order for A to call B, it's an RPC call. That's a lot more complicated. You have to program to deal with well, number one, speed of light suddenly is important. Network latency is important. Then you also have to program to deal with partial failure as well. So A can call B, but B might not be up, or it might be slow, and you have to program around that. And so you just got all of this complexity of distributed systems development that you didn't actually have to deal with. Oh yeah, and you also had to figure out where B is, right? Because you've got to do some kind of service discovery. And, so you've gone from writing simple Java code or simple Ruby code to distributed systems programming. And that's kind of painful. And then also sort of worthy of special mention is the fact that, if we decompose the system, then we sort of decompose the databases, and now we have to deal with, implementing transactions that span multiple databases without actually using two-phase commit. And that's kind of painful as well. Pain. There's lots of pain. Testing is painful, or can be. Whereas before, if we wanted to test the application, we just spun up our WAR file, made sure it was talking to a database. But now when we want to test our service, there's a whole bunch of services that it depends on. And they have to be launched as well. So that's complexity. I mean, in a way, the nice thing is many of these problems are solvable with the right level of automation. So it's not like they're sort of unsolvable problems. And then also we're now deploying this distributed system. We can't just copy a WAR file onto our Tomcat server. We've got lots of moving pieces that have to be rolled out. And then actually diagnosing faults is challenging because the request might have touched multiple services, and any one of which could have failed, and actually sort of diagnosing the root cause can be quite time consuming, especially if different services are owned by different teams and you actually have to communicate, and fault resolution can take a while as the trouble ticket gets bounced around. And also, whereas deploying changes within an individual service is incredibly easy, deploying changes that span multiple services requires a lot of careful coordination and sort of to actually, you have to start at the bottom of the dependency tree and roll out the updates and move up. So that's kind of complicated. Yeah, automation.